Have you ever just stopped and wondered what kind of magic is happening in that split second after you open an app like Twitter? Well, today we're going to pull back the curtain and actually build that magic. We're going to design the system that creates your social media feed from scratch, and you'll see it's all based on this one surprisingly simple and really elegant algorithm. So let's just jump right in. Think about it for a second. You pop open an app and your feed is just there, instantly. But behind the scenes, the system is sifting through thousands, maybe tens of thousands of posts from hundreds of people you follow, all to find just the 10 most recent ones. How on earth does it do that in the blink of an eye? All right, to solve this puzzle, we have to start thinking like a computer scientist. And that means we got to break this big problem down into its most basic parts. What are the absolute must-have tasks our system needs to be able to do? Really, it all boils down to this single, crucial function. You give it a user's ID, and it has to spit back the 10 most recent tweets from that user and everyone they follow. Everything has to be sorted perfectly by time. That's it. That's the core mission right there. And, to make that main function work, our system has to be able to handle these 4 basic actions. You got to be able to post a tweet, follow someone, unfollow them, and of course, get your news feed. These are the fundamental building blocks for pretty much any social network. Okay, so before we can even dream of building the timeline, we need a really smart way to organize all this data. Choosing the right data structure from the get-go, that's the real secret to making everything blazing fast later on. So here's our blueprint. For all the follow relationships, just picture this web of connections, right? With little arrows pointing from a follower to the person they follow. And then, for each user, we're just going to keep a simple chronological list of their tweets. Nice, clean, and totally straightforward. Now, to really wrap our heads around how we're going to merge all this data together, let's step away from the code for a minute. We're going to use a simple visual analogy that makes everything click. I want you to imagine this. Every single user has their own vertical column of sticky notes. Each little note is a tweet, with the time it was posted written right on it. And whenever someone posts something new, they just slap a new sticky note on the very bottom of their column. So the note at the very bottom, that's always the newest one. Okay, you got that sticky note image in your head? Good, because now we're getting to the real core of our solution. I like to call it the magic tray method.
So here's the real puzzle. Let's say you follow, 100 people. That means you've got 100 different columns of sticky notes, plus your own. How in the world do you efficiently find the 10 newest notes from all of those columns combined without having to look at every single tweet? This is where our magic tray comes into play. Okay, step 1. You go to your own column and the columns of everyone you follow, and you just grab the newest note, the one at the very bottom of each. You take all those notes and you place them into this magic tray. Now here's the cool part. The tray automatically just shows you the single newest note out of that whole bunch. So you take that one out, that's the first item for your feed. Then you just go back to the column that note came from, you grab the next newest one from that same column, and you put it back in the tray. And again, the tray shows you the newest one overall. You just repeat this process 10 times and boom, you have your perfectly sorted feed. This is the algorithm in action right here.
Now, of course, our magic tray isn't actually magic. In the world of computer science, it has a proper name. It's a priority queue, and it's usually built with a data structure called a heap. Its entire job is to hold a collection of things, and no matter what you put in, it can tell you which one has the highest priority. For us, that's the newest timestamp, almost instantly. And this is where you can really see the massive advantage of our method. The, naive way to do this would be to gather every single tweet from everyone you follow, throw them all into one giant pile, and then try to sort the whole thing. Can you imagine trying to sort thousands of tweets every single time you open the app? It would be a nightmare. Our magic tray method is so much smarter because it only ever has to look at a small handful of tweets at any given time, just one from each person you follow. So we've got our algorithm. Now let's connect it to the real world of software engineering, where things like performance and making smart trade-offs are absolutely everything. Okay, I know what you're thinking. A slide with a bunch of math on it looks a little intimidating, right? But stick with me here, because this is actually the secret sauce. This is what's called Big O notation, and it's basically the mathematical signature of our algorithm's speed. Think of it as a report card for how efficient our code is. All that complex-looking formula really means is that the time it takes to get your feed depends mostly on F, which is just the number of people you follow. It doesn't depend on the total number of tweets they've ever written, which is huge. And since K, the number of tweets we want, is always a tiny number, like 10, the whole process ends up being incredibly fast. You know, this whole approach we've been talking about, it has a name. It's called fan out on read. All that means is we do the work to build your feed when you ask for it, when you read it. Now, the other way to do it is fan out on write. In that model, every time someone posts a tweet, the system immediately pushes it into the timelines of all their followers. This makes reading a feed super fast, sure, but just imagine a celebrity with 50 million followers post something. The system would literally have to do 50 million updates all at once. That would make posting a tweet incredibly slow. So our method completely avoids what engineers call the celebrity problem. So if you ever find yourself in a technical interview talking about this stuff, here are the key things to remember. First, it's a small detail but an important one. Don't forget to include the user's own tweets in their feed. Second, really hammer home why the heap-based merge is just so much better than a simple brute force sort. And finally, mentioning that fan out on read versus on write trade-off, that shows you're not just thinking about an algorithm, you're thinking like a real system designer. So when you boil it all down, the entire design really comes down to 3 simple ideas. You use sets to keep track of follows, you use simple lists for tweets, and you use a heap, our magic tray, to merge it all together efficiently right when you need it.
And there you have it. That's how you build a social media feed from the ground up. It's a design that's simple, it's elegant, and it's incredibly fast. But really, it's just the beginning. Now that you understand this core logic of merging different sources, how would you change the system to handle something like retweets? That's the next puzzle for you to solve.